So we're now moving on to the third part of this inequality section, and we're just going to be focused now on how to graph inequalities. All right, so we're now finally going to be finishing up this little section that we've been working on. We've already learned how to know the difference between, or we already learned the difference between an inequality and the equation. We already know how to represent our inequalities using our different symbols, meaning our less than or equal to, our greater than, and our greater than or equal to. And we already went through how to translate from a sentence into an inequality. And the last thing that we're going to be covering now in this video is how to graph inequalities. All right, so there's something real quick that we're just going to go through before we start going through any problems, but this video should be much quicker than the ones that we have been doing. All right. If you recall, when you guys were doing your pre-assessment for your inequalities, there were some graphs in which we had an open circle and there were graphs in which we had a closed circle. So when we see that, it actually tells us two very important things. Anytime that our inequality is less than or greater than and not equal to, so let's just say x is greater than 3, it is going to be an open circle when we are graphing our graph. So if I were to say, let's say that this is 2, 3, 4, 5, and 6. If I'm graphing x is greater than 3, my circle, when I draw on my number line, is going to be open. And then we're going to go through how we know which way we are going to graph this, but this is what my graph would look like. So in this case, when I see the open circle, it's telling the reader that it's just greater than that or just less than that, and it's not equal to. So it means I cannot use 3 as my solution, but I can use, in this graph, I can use any number to the right of 3 or any number that's greater than 3 in my solution. All right, so whenever we see these open circles, it's telling us that it's just greater than or just less than. So same thing, if I see x is less than or equal to, let's say, 4. Well, let me just write in these numbers again, 2, 3, 4, 5, 6. Well, in this case, since it's going to be less than or equal to, I know it's going to be a colored in circle on that number 4, and this is what my graph would look like. All right. I will go through exactly how we know which way that this graph is going to be facing, whether if it's going to the left, going to the right. But the main thing that you need to know right now is that when there is a colored in circle, that is telling the reader that it is equal to it as well. So that means 4 would be a possible solution for this question. So whatever it is, whatever our question was, I could substitute 4 in for it and it satisfies it because it's colored in, and that tells me it's also equal to that. Well, whenever it is just an open circle like we have here, that means it is just greater than or just just greater than or just less than, not equal to it. So in this case, our value 3, if we were to plug it in, would not satisfy it because 3 is not greater than 3, where in this case, 4 is less than or equal to 4. So that's why it's very important that you understand the difference between when we have a colored in circle versus when we have an open circle. All right, so that's something that you must write down, that you must have in your notes, and that you must know. All right, it's very important not only for now, but also in the future. And knowing this difference between a solid, something that's solid, this is a solid circle, and something that's not solid, that's also going to help you when you guys are going to learn how to graph linear inequalities because you kind of use the same ideas. All right, so let me go ahead and we're going to now start going over a couple problems. All right, so we're going to go ahead and go through some of these problems now. And what I'm going to do is I'm going to explain what I would suggest you do for right now. And then we're going to learn a different way we can do this in a couple examples. So that way maybe you can streamline it, make it a little bit easier for you. But there's one really crucial thing, though, that some people forget to do when they're trying to do it faster, and it will oftentimes lead to some mistakes. All right, so the first way I'm going to show you is a way that will never make a mistake, no matter how it's written. So in this case, when we are graphing this, we see x is greater than 6. When we're graphing this, it must have x all by itself. So something that we're going to learn in the future, if we have like x plus 2 is greater than 6, we can't graph this until we get x all alone. All right, so we need to isolate x just as if we're solving for it as an equation. We isolate x all by itself. And once we get our inequality where it says x is greater than, less than, equal to, whatever it is, to some number, then we can go ahead and graph it. And whatever number we have here is the number that we're going to start with. So first I look at my inequality. I say, okay, is it equal to, or is it just greater, or is it not? And since it's not equal to, remember, this is going to be an open circle. So at 6, I will go ahead and draw an open circle. Right now, from there, what I'm going to do is I'm going to pick numbers on the right-hand side of this so I can act. Let me just draw like this little dotted line. This circle now is cutting my number line into two different regions. All right, we have our right side and we have our left side. And what we're going to do is we're going to pick any number on either one of these sides. So I'm just going to pick 10 for this. And I'm going to plug it in for x. Is 10 greater than 6? Yes, it is. So that means that this side of the region is going to be a solution. So I know that my graph is going to have to be on that side. All right, and if I go and try a number from the left-hand side, let's just try 0, because 0 is really easy to work with. Is 0 greater than 6? No, it is not. So I know that this side is not going to be a solution. So what we can do is we can test a number from each side of our region to see, well, which side actually holds true. And the side that holds true is a side that we're actually going to have to draw our graph on. So since 10 satisfied and 0 did not, I know that my graph is going, let me draw this, see if I can draw a little bit better. I know that my graph is then going to go on this side. So this graph is telling me all of the numbers that will satisfy. So you see here, it's including that number that when we plugged in actually worked. 10 was greater than 6. If I were to draw my line going to this left-hand side over here, then none of these numbers would work and it would not be true, right? So in this case, we are then drawing our graph to the right. And it's important that you draw it with the arrow at the end like I just did there, because that tells us it's going infinitely long, that it's never ending. And remember, this has infinitely many solutions for it that we can actually plug in that are greater than 6. And by drawing the arrow at the end, you're telling the reader that even though my graph is done here, my line will continue and keep going forever and ever. All right, so it's really important. If you just drew it like this, sorry, I don't know why it's zoomed in there, but if you just drew it like this, you won't get full credit for that because you're telling me that it actually ends on that spot. We're treating this as if it was like a closed-in circle. All right, let's do another example. All right, so we're going to first do this one doing the way that we already know, and then I'm going to talk about another way that we can do this. All right, so the first thing we do is we identify the number that our inequality is being compared to. We look at the inequality itself. Is it colored or is it open? It is going to be colored because it's equal to. So at 6, I will put a colored in circle. All right, then I'm going to look and say, all right, this is being broken up into two different regions. So now we have our left region and we have our right region. So I'm going to pick two numbers to test. So let's just go ahead and test 10 and 0. So I'm going to plug them in. Is 0 less than or equal to 6? Yes, it is. And is 10 less than or equal to 6? No, it's not. So that means that this left-hand side was the side that it is going to be satisfied on. All right, so I'm going to erase this because one thing you're going to see me do a lot is when I'm actually drawing these, because sometimes you can't see your work, especially if you're drawing in pencil. It's hard to see the number over the number line. You'll oftentimes see me draw above it like this. I mean, I don't have a ruler to draw this straight. You should be using a ruler when you're in class. But using this drawing pad, it's really hard to actually use a ruler. So oftentimes you'll see me draw it above it, and that's fine as well. And the reason why that could be fine is when you have your pencil, if you're drawing it on your number line, sometimes it appears to be colored in when it's really not. It's just easier and neater for you to see when it's above it like that. But anytime that you see me do one like on a computer or something like that, like when it's already pre-drawn or one that might be on your test that you need to read, it would already be filled in for you where it's on it. But you'll oftentimes see me draw it above it just because it's neater and it's easier for everyone to read. All right, so we already learned how to do this way where we're plugging in. Well, one of the ways that we can actually do this, and it's important, very, very important. Let me pause this real quick. All right, but the other way I'm going to show you what's very important is the variable must be on the left-hand side. So that means if our inequality was written as 6 is greater than or equal to x, we would have to rewrite this. All right, we can't read it like this if it's on the right-hand side. The variable must be on the left-hand side, and once it is, our answer to our inequality is actually the way that our inequality is pointing. If see here how it's pointing to the left, well, that tells me that as long as if my variable is on the left-hand side, that's the thing that people always seem to forget. They skip that step. But whatever side it's pointing to is actually the side that we're going to be coloring in. So if you see here, x is less than or equal to 6, it's pointing to the left. That's telling me that my inequality is going to the left. If we were to have x is greater than or equal to 6, so let me just go ahead, I'll do this down here. If we had x is greater than or equal to 6, well, since my x is on the left-hand side, it's the first thing you must look. that is telling me it's pointing to the right, that means it's actually going to be going to the right. So these inequalities we can actually use to help us in determining which way our inequality should, or which way our graph should be written. But the key thing, and this is where a lot of people forget, is your variable must be on the left-hand side. If it's not on the left-hand side, you can't just read your inequality. And even so, every time you graph this, you should always plug in a number and check to see if it works. So if I were to graph this green one and said x is greater than or equal to 6, and I drew it like this, I should pick a number. I'll pick 10 and plug it in. Is 10 actually greater than or equal to 6? Yes, it is. So that means I did color it on the right hand, on the correct side. All right, you're going to learn in the future when you get into higher level math, a bit harder problems where you're actually going to have what's called compound inequalities, where you have lines going in all different directions. And in that case, you would have to test your multiple regions. But for us, it's only broken into these two different regions. And for us right now, we're only going to have one side that is going to satisfy. But in the future, though, just remember, anything I teach you now, we're teaching you the basics. And as you learn in 7th, 8th, 9th, and high school, and you learn more things, there might be different steps that you may have to take to satisfy those particular problems. All right. So let's go ahead. We'll do one more example before we go ahead and move on to the end of this video. All right. So when we see this problem, 3 is less than x. If you want to go ahead and just test it every time, you can do that. So in this case, I see it's going to be to the 3. It is just less than or greater than. It's not equal to, so it's going to be an open circle. So I'm going to go ahead and put that there. I'm going to then draw my tested region here and see, okay, let me test my right-hand side and let me test my left-hand side. I will pick two numbers, let's say 0 and 10. I will plug them in. Is 3 less than 0? No. So we know that this region isn't going to work. And is 3 less than 10? Yes. So then we know that this region is going to work. So that means I can go ahead and draw my graph this way. Now, based on the information I just told you, I said that the inequality tells you which way your line's going to go, whichever way it's pointing. So if you look at this, you might have said, oh, well, why isn't it pointing to the left? Remember, you must rewrite this so that your variable is on the left-hand side. So I'm going to rewrite this problem. So I will start with writing x. Now I'm going to look and see, is my inequality opening or closing towards my x? It is opening towards it. So that means it must still be opening towards my x here, right? It's not just we just rewrite the inequality exactly how it is. We have to think about what the original problem was saying. And then we know that it's going to be x was greater than 3. And once it's rewritten on our left-hand side, now if you look, our inequality is pointing to the right. Our answer went to the right. All right, so you'll always be able to just test your regions like I did. And if you feel comfortable with that, it only takes you a quick second to do that. So it's not like you're doing much more work. But if you wanted to, you can also get in the habit of writing the x on the left-hand side. And then from there, you can just read what the inequality is saying. It's completely up to you, whatever you feel more comfortable with. All right, that is it for this video.